Okay, so our next speaker is Shujaur. Shujaur, who's Senior Manager at Red Hat Telecommunications, Entertainment and Media Partnership Organization. He's responsible for managing a team of technical professionals, partner SAs to develop and deploy cloud technologies utilizing Red Hat products and services. And Shujaur has over 20 years of experience working in the telecommunication industry. Prior to joining Red Hat, he spent 14 years at T-Mobile US, leading high-performance engineering teams, enabling 3GPP and non-3GPP architectures and technologies in the telco 4G, 5G domain. In addition, he has led NFV cloud tech strategy, contributing to the company's transition from legacy networks to the software-defined cloud infrastructure. Let's welcome Shujaur.
Thank you, Irfan. Thank you for having me today. I think that was a perfect match. We just talked about the open source, and for all who does not know Red Hat is a leading open source company, and they are the leading contributor to upstream community as well, starting with Red Hat Linux contributions, all the way to OpenStack, Word in the telco, and then containers with OpenShift, continuing on the telco journey. Okay. With that, anything not automating is slowing you down, which means that any time that when you have to do some manual tasks, that will increase your time to deploy and time to execute. So let's look at the mobile network deployment scale. As we know, I mean, this presentation is about the automation for Open RAN and 5G core. We all know that mobile networks, it's a sliding scale, starting from the access side, where it has the large cell site deployments carrying into the edge, which is a compact clusters, into further down in the central data center, which is a form of multiple applications consolidating into a big infrastructure. So there's a different scale that varies all the way from access towards the core, combining smaller applications into multiple applications and big clusters. So automation varies. And as we talk about the Open RAN with multiple CUs and the thousands of DUs that we have to deploy in the network, your automation has to scale accordingly in order to match either the scale of the deployment or the multiple application that has to be deployed as a part of the core network. The one benefit that we have today jointly is the world is CSPs are realizing about the cloud native benefits. I started my journey with the monolithic applications, 2G, 3G, big networks, everything tightly integrated. Went into the NFV journey where we started abstracting some of the software and hardware layer, and now into the path of cloud native, which is further abstracting your hardware, your software, your applications. It creating an opportunity where everybody is playing its role. At the same time, it is also enabling some of those principles for cloud native in terms of DevOps, microservices architectures, your containers, which actually provides the further benefit and enhancement towards the whole ecosystem of telco vertical. Now let's talk about automation and GitOps. Look at the automation journey. We started pretty slow. Like that was just initially, again, I talked about the monolithic application, everything tightly integrated, started with the manual tasks, manual work that has to be done, slowly starting with the automation, some sort of repeatable task, created a small script, execute about 10 commands, put it in a small shell script, execute it, it helped. And then further adding some of those automation tasks into repeatable workflows. Let's say if you have to do a software upgrade and you have 5 different tasks that you have scripted, you create a whole workflow that will further um, orchestrate a workflow. So that's how starting from traditional provisioning to automation to orchestration, and then went into infrastructure as a code. This is where some sort of divergence started to happen, where the industry started to realize now, especially with the NFV world in the telecom domain, when there's a software and hardware abstraction, all of a sudden there's a big infrastructure that you have to manage as a part of the application. So some sort of infrastructure as a code or configuration as a code, some of those ISE, CSE, those principles started to come along, where now you're deploying your whole configuration, your infrastructure as a code, you're putting that in the wrapper, and that will execute your whole infrastructure and some sort of zero touch provisioning along with the DevOps principle. Further into on the RAN side, SON, self-organizing networks, that actually enhance the ability for RAN network to self-monitor, self-configure, and self-feed. So that helped the benefit, while the core was helped with these other principles, infrastructure, configuration as a code, overall DevOps principle. RAN side also helped with this, the self-organizing concept. Now everything is transitioning into the GitOps, the concept that was introduced a few years ago, that actually combines all of these things together. It provides a continuous reconciliation, provide declarative operations. We'll talk about it further in the slides, and it also provides a mechanism for zero touch provisioning. Now let's look at the existing automation practices. Three different ladders for existing practices, starting with traditional provisioning as an example. We used to provision configurations, went into some sort of automation that we just talked about, into the orchestration, some sort of workflow that actually configures your whole application or the infrastructure. Your traditional development cycle started with simple software development cycle, software upgrades, went into this, the waterfall method, went into the CI/CD. That was one enhancement that brought in the faster software upgrades with continuous integration and continuous development, created this whole life cycle of starting your planning, your code build, all the way into your release and deploy, with agile methodology come in the middle, which actually dividing your whole software development cycle into multiple sprints, where you can develop multiple sprints, and at the end you can connect them together. With your traditional operations, started with the manual operations, went into a more streamlined method with ISE or configuration as a code, mentioned into SON, which is managing your infrastructure, went into artificial intelligence within your operations network. So AI ops got in some AI and ML within that. All of these framework got combined into the DevOps principle, which has been pretty popular from the last many years, and that has been followed. We have created the role of DevOps engineer, created the role of SRE, site reliability engineer. They are managing this whole ecosystem of provisioning, development, and operations, and get into this whole network as a code, where now you're managing your complete network operations as a code, part of the DevOps. And then this GitOps principle got introduced back in 2017. So GitOps is not a framework. It follows your existing practices, your existing frameworks such as DevOps, but it provides you some sort of best practice method to use Git as your single source of truth. And we will talk about it in the further slides. So just to remember, it is a form of best practice. It works with your existing practices in order to enable you for autonomous or zero touch operations. What is GitOps? The development-centric approach to continuous delivery and infrastructure operations. As I said, the first thing, The first thing is treat everything as a code. This is the first principle for GitOps, which means that anytime that you have to deploy infrastructure, you have to deploy an application, you have to deploy, you have to make some configuration, it has to be treated as a code, which means it is declarative. Single source of truth. Git is a single source of truth. Git stands for Global Information Tracker. Even I did not know about a year ago. So it is a form of your single source of truth. Everything that you have to deploy in the network that has the source is your Git. It is version control. The way it is started was as a part of some sort of a common or centralized tracker where you're managing and maintaining all of your configuration along with the version control that is available. And the last piece is RO reconciliation. So pretty much there's a whole RO reconciliation process that goes on. You start with everything starts with the Git. Once it is deployed, there's a reconciliation process that begins at that point. If there is any change in Git, you will go ahead and either redeploy or roll back or whatever declarative operations that you have defined. So it not just ends with the deployment, it then continues on, keep on monitoring the system with any changes that will happen within the environment. Why GitOps? First, standard workflow. It's not changing anything. It is using your existing practices. It's not changing any role. It is just applying the additional guidelines, how to apply some of those principles. Visibility and audit. It provides full amount of visibility. Your whole configuration is there. It is present. It is version controlled. There's an archive. You can go back to history in order to see what has been deployed, what time, when it was deployed. You would maintain this complete history with the GitOps. Enhanced security. It's every time you deploy a change, there is a certain security framework. There's a certain set of approvals required. There is some sort of certification or SSH keys that are exchanged between the systems in order to ensure that deployment is secure. It also provides multi-cluster consistency. I would say this is the foremost important thing because even in the telco world, the way we are dealing today, it is a multi-cluster environment. We are seeing, hyperscalers are also coming in, which means that there is some sort of deployment that will be hybrid on-prem as well as in the public cloud. There may be different clouds from different vendors. Now you have to all of a sudden deal with this multi-cloud and multi-cluster environment, and this provide a common framework, common consistency across your existing frameworks. GitOps principles. 4 principles. It's pretty straightforward, pretty simple. First, your system state is described declaratively, which means you define your current state and you define your desired state. And everything in between is treated as a code. In the past, we used this prescriptive model where, just like a doctor writing up prescriptions, you write a set of commands, you execute on the system. In that case, your system is dumb. You're just executing whatever you're writing. But in this case, your system is smart. You're actually describing the desired state of the system. But within that framework, you're actually keeping all of that the story along with it. Desired state is version in Git, which means that every time you have to apply a new desired state, it will create a new version in Git. Approved changes can be applied automatically. You don't have to, there's an auto approval process. It has a framework that if it meets a certain criteria, it will automatically either deploy the change or doesn't meet the criteria, then it will auto roll back. The last is controller exists to detect and act on the drift. This is the foremost important principle. Once you deploy a change, then there's a controller that keeps on monitoring the system, keeps on monitoring the Git. If there's any new change that has happened by your DevOps team, a new code has been pushed, a new config has been pushed, it is available in Git, has created a new version. That controller process will keep on monitoring. If it's available as a brand new version, then it will follow certain guidelines and principles in order to decide the next steps. GitOps controller, just talk about the last piece. Your configuration is stored, everything is stored in Git. We call it Git repo. It's a repository where you are storing everything, feeds into GitOps controller, and that controller is actually creating this whole reconciliation loop along with logs and monitoring to keep on that reconciliation process if there's any change. GitOps pipeline, start with declarative stage, start with your blueprints and manifests, feeds into your version declaration, which is form of Git repos, then gets into your continuous deployment cycle. It uses existing CI/CD pipeline. You don't have to build anything new. It integrates within your existing CI/CD pipeline. Either it's a form of creating a new container image, or it is in the form of deploying a new container image on the system, and then feeds into your auto loop system, where it will again start this whole GitOps controller will start this audit process. Now let's look at some examples for GitOps workflow. Let's say there's a application that you have to deploy. You define what is your current state, gets into your CD, your deployment pipeline, to your desired state that you would like to achieve. So let's look at the example. Your developers developed the code. He did this code commit in Git. Now you're in your Git repository, your new code is available. It feeds into your CI pipeline, your continuous integration pipeline, which will create your image registry. Once your image registry is created, it will feed back into Git. It will create a new version of using manifests and charts. It will create your new version of Git with respect to configuration, because now you have spinned up a new container image that requires another either same or different version of configuration. So now you have created another version in Git that will feed into your CD pipeline, which will deploy on your Kubernetes environment. And then the last piece is the controller piece. Once this deployment is successful, you have this audit process that will start along with that, which means that will monitor, detect, take action, deploy. And just to add the Red Hat piece here, so if you are using Red Hat OpenShift, which is one of our product for Kubernetes, then again, OpenShift GitOps will actually feed into CI and CD process. It will OpenShift builds and pipelines will feed into your CI pipeline, and GitOps will feed into your CD pipeline in order to provide this whole continuous integration and delivery process with the GitOps controller. Now let's look at the GitOps for core and Open RAN automation. Let's look at the sample deployment for 5G core and Open RAN. More focusing on the Open RAN because 5G core has been there. Open RAN has a big deployment challenge in terms of you have a large scale of DU deployments, tens and thousands of DU that you will have to deploy, and there are different models for DU deployment. Either it's a distributed RAN or centralized RAN, close to the cell site, or as the CRAN hub site for your DUs, and then your CU also depends. Either it's a near edge or the far edge, depending how close this whole compact cluster is deployed. And of course, your CU has a user plane and control plane that can be combined with your other applications like UPF for private 5G, or it can also be deployed as a part of your edge. So there are different Open RAN deployment scenarios. So let's look at how this framework can be used in order to deploy the large scale deployments for Open RAN, especially the DUs. Just a baseline requirement. As we know, I mean, DU has a large scale, will require tens and thousands of sites, will have the regions, multiple regions. Each region will have a different form of nodes that will have to be deployed. So node sites, regions, The scale is important for this deployment. Cookie cut approach, design once and deploy many, means that you don't want to create those artifacts or manifest for tens and thousands of sites, right? Not every single site has to create a new configuration. There's an approach called templating where you can create a template. Let's say San Diego is a one RAN cluster. You could template San Diego as a RAN cluster. Seattle is another cluster. You could template another Seattle cluster with a different baseline configuration. So it's a cookie cut approach. You create your design once, deploy many approach and create some sort of templates. Single source of truth. Again, Git repository is your single source of truth. You have to make sure that all your configuration resides on a single source where it is fully controlled, managed, as well as version control. And of course, the last is the version control, where you have to make sure you have to understand that this will means that you need to keep a track which configuration has been deployed, where which needs to be updated, etc. High-level provisioning flow, third-party site modeling on my right. So this is where you start. You create some of those manifests and your templates, your configuration templates. So that's what will be feed into your Git, which will create your Git repos, and that Git repos will actually feed into your zero-touch provisioning, which will actually go ahead and deploy the system. This is an operational flow. You start with your site design and inventory first. And for those who are part of the operators network, we use a term called CIQs, customer information questionnaire. That's where we store all the information about a particular site, particular node, particular set of configurations within an Excel sheet. So you start with the CIQ, some sort of site design, feed into your Git repos. There are several tools which are used in order to create some of those Git repos, create some of those configurations taken from either an Excel sheet, create the structure for Git repos, feed into your orchestrator and your controllers, which will actually go ahead and deploy on the system, and then afterwards will actually maintain it as well. Just an example of a Git repo. If you in the right side, there's a baseline configuration, which means that some of these configuration does not have to change for let's say a big cluster. I talked about San Diego cluster as an example. So this baseline configuration will remain same. So you create one template for baseline configuration, which means that within that template, you can deploy many sites within the same cluster. Then you create your blueprint for specific configuration, which means if you have to define some within the cluster, you have to define some site specific, some of those areas where you have to deploy the DUs. They may have a different naming convention. You wanted to make sure they have some sort of different cell and sector information. So you feed into that information, specific information. And then lastly is just your cluster deployment, where you go ahead and using your baseline configuration, your on top application configuration, go ahead and deploy your container cluster on top. Just an example of workflow, how this whole workflow would actually work. So your Git repo is on the left. You have your controller, so orchestrator, which is could be a traditional controller as well, and GitOps controller on the right. And just there is messaging communication that happens through webhook notification, and it's a notification framework and mechanism that actually informs the GitOps controller if there is some new version has been populated in the Git repo. So you just follow the progress along the Git repo and the controllers. So you could see, I mean, as an example, with zero-touch provisioning, you have to deploy this first configure infrastructure. The next, you have to deploy cluster. You have to deploy RAN configuration. You have to deploy CNF. So you define steps. Each steps will have some sort of within that each step, you'll have some sort of configuration steps, right? And then you're combining all those steps through Git repos. Every time you have to deploy configuration, you have to combine it with Git repo, but you can define that whole workflow in order to create a zero-touch provisioning, which will deploy starting with your baseline infrastructure level provisioning all the way till your application layer configuration. So few examples that I added just for reference, because we like to talk about the use cases. As an example, you're upgrading a non-RAN cluster, which means that in this case, you're just, I mean, it's a 5G core cluster as an example. You're doing a rolling upgrade. So as it gets the instructions from Git repo, it will actually goes to a GitOps controller. GitOps controller would actually check if it is the maintenance window that has been started. We'll go ahead and deploy the rolling upgrade to that cluster. And you can define some of those principles about the maintenance windows, etc. Upgrading an ORAN cluster. ORAN cluster would have multiple clusters in between, because your deployment could have been multiple cell sites with sites and sectors, and you want to cascade some of those deployments. So it's part of your multiple clusters where you want to deploy one set of sites first before you go into the follow-up site. So you define some of those framework and principles, upgrade your, let's say, in multi-cluster control plane first, then you go into your user plane, or you further divide into your small site cluster first, and then you go to the remaining sites. Another example, moving your front haul configuration from DU1 to DU2. So in this case, since you are moving your front haul from DU1 to DU2, you have to go ahead and first update in the Git repo that this is the action that you're taking. It will update, it will create a new version after it's remove DU1 from front haul and add DU2 in the front haul. It will spin up a new version, which will be sent as a part of webhook notification to GitOps controller, and GitOps controller will go ahead and execute the set of instructions in order to move from DU1 to DU2 for front haul. It's another example of configuration change in GitOps. Let's say you have your main GitOps branch that is here. We want to make sure that main branch is still keeps on running, and your development team wants to carve out or fork another software change or a configuration change within your main branch, and you wanted to make sure that rather than all the way pushing to your main branch, you wanted to test it on a test cluster first before you could actually merge it part of your main branch. So similar steps where your main branch is now forked into a smaller, forked into another test branch, and that test branch is created as a part of this CA process. And then in this step 5, it actually feeds into your CD pipeline where it go ahead and deploy in your test cluster. And if it is successful in your test cluster, you could actually merge it with the main branch. So in summary, GitOps makes possible end-to-end ZDP, which means it's a full stack zero-touch provisioning, starting all the way from the infrastructure, get to the cloud layer, which is where Red Hat comes in with Linux, OpenShift, form of your Kubernetes operations, comes to your application, say DU or CU on top, along with the next layer, which is your orchestration, SMO, and RIC that comes in your place. So it provides a whole framework for zero-touch provisioning all the way from infrastructure, BIOS level configuration, all the way till the application layer, even integrating with some of your principles with SMO and RIC. And it paves the way for zero-touch operations. I know we talked about the ZDP, which is zero-touch provisioning. And now it is the zero-touch operation, which is self-autonomous operations, part of your existing framework with ZDP, which is already achieved, plus your additional capability with observability, plus data analytics, plus AI and ML, combining into whole ecosystem of zero-touch operations. Lastly, just a slide about Red Hat, how Red Hat works within that framework. The left side is your planning and integration, which is your again your declarative state, which is all your inventory management, your site level design, third party tools and to manage your site design feeds into this your whole framework of cluster management, which includes your continuous deployment, your version repository with Git and closed loop automation. So everything that wraps around Git is managed through OpenShift and Red Hat, which means that as part of continuous deployment, it has a tool that are integrated within the OpenShift that actually follows the deployment path. It has the tools in order to create some of those templating that I talked about, where you have to deploy tens and thousands of sites. Not every site has to maintain a configuration. You can create some of those templating within the OpenShift that will actually ease your further operations. And the last piece is the part of your OpenShift GitOps controller, which actually provides this full closed loop automation, keeps on auditing reconciliation every time there's a change. Will actually go ahead and deploy. And lastly, while you're innovating your future, optimize what you have today. Thank you. Any questions? Yes.
Yeah. I have a question related to ORAN. So there's an ORAN is working group 6, I believe.
Right.
About the cloud and infrastructure and management orchestration. So how does all of this relate to the certification work that's going on in ORAN?
Okay. So ORAN, yes. So question is regarding ORAN Working Group 6. That is overall managing the automation framework. It defines O2 IMS interface, which is primarily to provision your infrastructure. It has about 6 APIs that are being proposed. I would say it's still work in progress. I have not. I mean, I would say GitOps framework is outside of the what they will propose as a form of the specification, because they'll just propose the final state. This is how it should happen. But at the same time, the framework that you have to manage there may, I mean, it may happen differently. Differently means they will not define some of those tools, and as an example, they'll not dictate some of those tools that you have to use in order to achieve that purpose, right? So they'll just define the specification. And as I said, I think there are about 6 APIs that they have defined right now in order to manage your whole infrastructure automation. And I know there has been some changes being proposed as well within that working group, but they will not define what sort of tool that you need to use. They'll just define the principle that you have to follow. So there would be some sort of mix, I would say, because in my view, some of these things has to integrate with the SMO and the RIC as well, because I call it as CMO. It is it's kind of a new term created on my own. Cloud management and orchestration, because anything that you have to manage cloud down, your application above does not have the visibility. So ultimately, that integration has to happen in a way where it is a seamless operation across your full stack. So, I mean, just to summarize, the working group will not will not dictate some of those tools that you have to achieve this full scale simulation. Simulation.
It's up to the operator.
It is up to the operators.
Comply with the specification, not up
Correct.
to Reddit.
Correct. That is correct.
Any questions?
This is all the nice communities too. But I saw one in the other part under one of the slides. It was the OSM. Is it the OSM model, public model? On the left, SMO. Oh, okay, no, it's SMO. Sorry.
Yeah, it's SMO. That must have been a good catch.
So thank you for the presentation.
Sure.
Maybe one small question. So I mean, what I've heard, seen is that already DevOps something is very complicated. Maybe it should start differently. So this GitOps is more like a role for people, it's more an organizational thing. And if it is a role for people, then I mean already in DevOps there's quite a lot of complexity. And again, this means that for certain people is very, very good to oversee the whole thing. Maybe then also one step further is in this. I mean, I guess there are of course checks for errors on every step, but in the end you have kind of a cascade of things that happen just with a simple commit. So that can maybe have the devastating effect where somebody introduces some bug that then propagates down the whole line of action.
Right. No, I think that's a great question regarding the DevOps being the it's already complicated. Now we are adding another complication with GitOps, and anything in the pipeline can break, right? Can be introduced. So I agree. DevOps started with three things: people, process, and technologies. You combine all three things, and you created a role that would actually follow your the whole the ecosystem of the managing the change, deploying the change, and GitOps added additional complexity. Now you have to manage this whole artifacts and right. But at the same time, I think it also helps DevOps, in my opinion, because in DevOps you may not have that level of visibility what is going in the system, right? You're just following the pipeline. The pipeline and DevOps engineer is developing the code, building the code, ultimately pushing the code, right? But it would never have any reference to go back and reconcile. There's not a reconciliation process that exists in DevOps, and that's what GitOps has added. This is a reconciliation process, and of course, it adds to a bit of work for DevOps engineer, but actually, in fact, it helps them. So the last part where if um, some code malfunction has happened along the way, you would have more visibility in the system in order to catch some of those in advance. Plus, some of those reconciliation process has some sort of notification. So every time there is something doesn't match with the reference, which is your Git repo, you'll automatically be flagged. And DevOps engineer can make a decision what to do with that notification flag that I have. I mean, how do I need to act on it? So it gives, in my opinion, it makes it easy, a bit easy for them, because now they have this visibility within this whole pipeline. Okay. Thank you.
Thanks a lot, Shujaur. So yeah, Red Hat is one of our partners. We manage clusters based on Red Hat OpenShift, and the relevance is also deployment of OAI on these clusters. So different components like the core network, the CU, etc. So this is an ongoing big activity outside of our development of the stack itself. Red Hat is a great partner there, provides us all the tools, and we work together on a regular basis. So thanks for that. Great talk, Shujaur. Thanks.